Alright guys, so what's up guys? It's Damari.
What's up here? What's going on here, huh?
And today I'm going to be explaining to Max what conic sections are for
What?
what class is it? Pre-calculus. Alright Max, so you know what a cone is, right? Like
Yeah.
a geometric cone.
Like
And-
a 3D cone or?
Yeah, a 3D cone. Now, like imagine like you have like a plane, right? Like a plane.
Yeah.
It's like horizontal, and you cut through.
Ooh,
You cut through that cone.
that's quite interesting. Wow.
What happens when you do that is that different kinds of surfaces appear on the plane, depending on the angle at which you hit.
And also the height, I would assume.
Yes, the angles at which you hit the cone.
I don't know. There's
These
like
different shapes, they can be classified in 4 ways. There's the circle, the ellipse, the parabola, and the hyperbola. These are conic sections.
Could you repeat that real quick?
Which one?
All the four types again.
There's the circle, the ellipse, the parabola, and the hyperbola. So let's start with the circle. Or I'll use it as an example so you can understand this a bit better. So as you know, a circle is like all the points that are like equidistant from one central point, right? It's kind of weird how you just cut through a cone and it's like that, right?
Oh. So that would be like perfectly even.
Yeah. And what's even more interesting about it is that you can graph it. So you know the Pythagorean theorem, right? X,
Yeah.
A squared plus B squared equals C squared. You remember?
Yeah.
Alright, so if you replace A and B with X and Y, that would give us a circle.
Yeah.
Remember the circle equation? Yeah. Because think about it. It's literally just a Pythagorean
Yeah.
theorem. So it's just a
That's
bunch
true.
of right triangles that all satisfy that equation.
Oh, that's a good way to think about it.
And our hypotenuse is all the same length. Yeah.
Oh, that's pretty cool.
That's just one example of how you have conic sections and they turn into graphs. It's crazy stuff. What do you think?
I like that. Now, could you go into like the hyperbolas and the parabolas? I thought that might be even more interesting. What are those really when you cut into that? What does it really look like?
Okay. Well, the parabola is formed by. It'll be difficult to describe it artificially, but when you rotate the plane a certain way, you would get a shape that looks like a parabola. And the parabola is described as the set of points that are equidistant from a directrix, which is like just a straight line in a graph that's horizontal, and a focus, which is just one central point. So you can think of like drawing like isosceles triangles, like vertically
Right.
or diagonally through all the points, and that's how the parabola is formed. The hyperbola is the strangest one of all of them.
I would imagine.
Yeah. You intersect the cone at different places, and it kind of looks like 2 parabolas going off in infinite directions, but it's very different. I don't want to go through the trouble of explaining it.
Thank you, Demar.
But yeah,
It's very
thank you
helpful.
for participating here, so I get a grade.
Uh,
Mr. Coppins, give me 100. Thank you.
I'm not